everyone, I hope all of you are doing good, and today I am here with cubes and cube roots class 8 maths, and in this video we are going to learn about the basics of cube and cube roots and how do we handle them. I am Roshni from LearnoHub, the free learning platform where you get to study maths and science absolutely for free at learnohub.com. Now, what comes to your mind when you think of a cube? Maybe a shape like this? A three-dimensional shape with all the edges equal. That's a cube, right? Now, an interesting thing that we notice is there are some specific numbers which are capable of forming a cube. Now, you may be wondering, what am I saying? Why are there some specific numbers which can form a cube? So, we will look at it in more detail with calculations, right? So, the only concept that you should know is, how do we calculate the volume of a cube? Side into side into side. That is side cube, right? So if each side measures, let's say 2 centimeter, then the volume of the cube is going to be 2 cube, that is 8 centimeter cube, right? So that is the basics which we already know. So now let us take a look mathematically that why are there only specific numbers which can form these cubes. Look at it in this way. How do we find the volume of a cube? Now, there exists cube of many different sizes, right? So, how do we know how big a particular cube is? By knowing its volume, right? So, volume tells us how much space that entire cube occupies. And how do we calculate that volume? So, let's take this example. So, in the first case, this is our first scenario where we have just one cube. And let's say that the length of each side of this cube is 1 centimeter. Now, in a cube, all sides are equal. So, each of these sides measure 1 centimeter. So, what would be the volume of this cube? How do we calculate volume? Volume is side into side into side. So here all the three sides are equal. In fact, for any cube, all the three sides would be equal. So what is the volume? 1, that is the length of each side multiplied 3 times. Right? So when we multiply 1 3 times, we can write it as 1 to the power 3. So 1 to the power 3 is nothing but 1 cube, and 1 to the power 3 is equal to 1 centimeter cube. So the volume of this cube is 1 centimeter cube. Now let's look at the second scenario. So in the second scenario, let's say that we have these kind of cubes, but multiple number of such cubes. Like here you just had one cube and the volume of one cube was 1 centimeter cube. Here, instead of having one cube, how many cubes you have? This is cube number 1, cube number 2, cube number 3, cube number 4, cube number 5, cube number 6, cube number 7, and again at the back side you will have cube number 8. So here you have a total of 8 cubes. So when you have these 8 cubes together, it forms a bigger cube. Why? Because now the length of each side is not 1 centimeter. Instead, it is 1 plus 1. That is 2 centimeter. So the length of each side of this cube is 2 centimeter. So what would be the volume of this cube? So the volume of this cube would be 2 into 2 into 2. That is 2 cube, which is equal to 8 centimeter cube. Let's look at yet another scenario, that is scenario number 3, where you have even more number of cubes, but here also all of them together form a cube. So here what do we see? How many cubes do we have? Let's count. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and in a similar way, you have it at the back side as well. Right? So that's how you can count the cube. Okay, so total how many cubes? So another easier way of counting the number of cubes is you count layer by layer. So here you have 3 layers. So the first layer you have 1, 2, 3. Let's number 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 small cubes in one layer. So in 3 layers, how many total cubes you have? 9 into 3, that is 27. So 27 small cubes together again form a bigger cube. This time the side length is 1 plus 1 plus 1 centimeter, which is 3 centimeter. So what is the volume of this cube? So for this big cube, the volume would be equal to 3 into 3 into 3, which is equal to 3 cube, that is 27 centimeter cube. Now what do we see? We see that there are only a fixed number of cubes. When you take 8 small cubes together, you get a bigger cube. Again, when you take 27 small cubes together, you get a bigger cube. Now let's say that instead of 27, if I give you 20 cubes. So can you think of any possible arrangement where by using 20 cubes, you will be able to get a bigger perfect cube? No. Every time you arrange those 20 cubes in any form, you will always get a cuboid, because with 20 cubes, you will never be able to have an arrangement where the height and the width and the length of the formation is equal. So sometimes the height will be lesser, sometimes the width will be lesser. So you will always end up having a cuboid. So that is why these numbers like 1, 8, 27, these numbers are called perfect cubes, or these are called cube numbers. Now here I have explained the concept by taking the analogy of the cube, that is the three-dimensional cube structure. So now let us talk about the cube numbers in terms of numbers. So what are these numbers? So these are numbers which are obtained when a number is multiplied by itself 3 times. So any number which you can get by multiplying the same number 3 times. For example, if you take any number, think of any number that comes to your mind. Let's say you think of the number 52. So if you multiply 52 3 times, what do you get? It is 52 cube, obviously, and whatever value you get after this, so that value is a perfect cube or a cube number. So perfect cubes are cube numbers are also called perfect cubes. Why? Because these numbers are such that if you arrange these many numbers of cubes together, that will form a perfect cube. Like how you saw in the previous slide, that if you have 27 smaller cubes, you can make an arrangement which will form a perfect cube. Similarly, if you have 52 to the power 3 number of smaller cubes, you can again get a perfect cube. So that is why the name perfect cube. Okay, so let us look at the cubes of the first few numbers. So 1 cube is what? 1. 1 into 1 into 1. Similarly, 2 cube is what? 2 into 2 into 2. That is 8. 3 cube, 4 cube, 5 cube, and so on. And in these, which are the perfect cubes? Which numbers are the perfect cubes? So this number 1 is a perfect cube. 8 is a perfect cube. 27 is a perfect cube. 64 is a perfect cube. 125 is again a perfect cube. So each of these numbers, they are perfect cubes. Now you might ask that after 1, so 1 is like the first perfect cube, and after 1 you have 8. So what happens to the numbers that exist in between, like 2, 3, 4, 5, 6, 7? Now all of these numbers are not perfect cubes, because like you are cubing the numbers consecutively one after another. So after 1 you have 2. Right? So you have cubed 1, you got 1. Now when you are cubing 2, you are getting 8. So that itself tells you that all the numbers between 1 and 8, they are not perfect cubes. Similarly, all the numbers which are missing between 8 and 27, they are also not perfect cubes. So these are some special numbers which are perfect cubes. So in this lesson, we are going to talk about these cube numbers or perfect cubes. So let us talk about the properties of perfect cubes. Now since these numbers are special, they also have some special properties. So the first property is cubes of numbers with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the unit digits will end with 0, 1, 8, 7, 4, 5, 6, 3, 2, 9 respectively. Quite complicated statement, isn't it? Well, but it is actually not that complex. So what it tries to say is, let's say that I have given you some big number. Let's say I have given you a number like this. 723 to the power 3. And if I ask you that, can you tell me the result would end in what digit? That is, what would be the unit digit of its cube? Now, it's very difficult for you to tell because you just can't orally do the multiplication of 723 into 723 into 723. That's difficult. So for that, what you can do is you can apply this logic. So we know the cubes of numbers from 1 to 10. Right? So we basically know the values of the first 10 perfect cubes. And knowing these is more than enough to predict the unit digit of cube of any number. How? That's because the unit, just focus on the unit digit of the number. Now this unit digit has to be one of the digits between 0 to 9. It has to be one of those digits, right? So what is the units digit here? So here the units digit is 3. So when you look at these values, cube of 3 is 27, right? So that shows that when you do actual multiplication, that is when you multiply 723 with 723 and then again you multiply the product with 723, you would see that during the process of actual multiplication, what happens is the units digit of the result is equal to the units digit of the product of the units digit of the number. That is, if 3 cube is equal to 27, where 7 is the units digit, that means that when you find out its cube, the units digit will be 7. So in the result also, the units digit would be 7. So that is why we say that cubes of any number which ends with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, their product or their cubes would end in these numbers, because 10 cube is 1000. So any number ending with 0, its cube will also end with 0. Any number ending with 1, its cube will end with 1. Any number ending with 2, cube will end with 2. Any number ending with 3, cube will end with 7, and so on. So just by knowing the cubes of the first 10 numbers, you can actually predict the units digit of the cube of any number. Cubes of even numbers are even. This is another interesting thing. So when you look at the pattern here, at least the first few perfect cubes pattern, you would see that any number which is even means the number which is completely divisible by 2. So here the even numbers are 2, 4, 6, 8, 10. So these are the even numbers. So when you look at their cubes, the values are 8, 64, 216, 512 and 1000, and all of these are even again. So cubes of even numbers are always even. Similarly, cubes of odd numbers are odd. That's because the numbers like 3, 5, 7, 9, they are odd numbers and their cubes are also odd. Now, perfect cubes also form interesting patterns, just like square numbers do. So whenever you observe any perfect cube, you would see that is a sum of consecutive odd numbers. Now again, you might be surprised that when we learned about perfect squares, there also we saw that perfect squares were sum of consecutive odd numbers. So how is it possible that perfect squares and perfect cubes, like they are showing the same pattern? Well, it is not exactly the same pattern. Let's have a look. So these are the first few perfect cubes that we have seen, right? So let's see how they are sum of consecutive odd numbers. So 1 is anyways 1. So when it comes to 8, you would see that 8 is sum of 3 plus 5. What is 3 and what is 5? They are odd numbers. They are consecutive odd numbers as well. When it comes to 27, it is sum of 7 plus 9 plus 11. So 7, 9, 11, they are again consecutive odd numbers. Now another interesting pattern is that if you look from the top, you see 1, the next odd number is 3, next is 5, next is 7, 9, 11. So basically it's in an order. So when you look at the perfect cubes in an order in the increasing order, you see that the consecutive odd numbers of which it is a sum, those odd numbers are also in order. So when it comes to 64, can you guess which are the numbers whose sum would be 64? So after 11 you have 13. So 13 plus 15 plus 17 plus 19 would be 64. Similarly 125, would be 21 plus 23 plus 25 plus 27 plus 29. So in that fashion, even without adding these numbers, you can just guess what would be, which are the numbers whose sum would be 216. It would be 31 plus 33 plus 35 plus 37 plus 39 plus 41. So in this fashion, what's happening? You see that it is the sum of consecutive odd numbers, and the number of odd numbers is gradually increasing. Like when it was for 8, what is 8? 8 is 2 cube. So there were 2 odd numbers, 3 and 5. When it was for 27, 27 is 3 cube. So there it was sum of 3 consecutive odd numbers. When it was 64, which is 4 cube, then it was a sum of 4 consecutive odd numbers. So now you see now you understand the pattern. So what happens is, every perfect cube is equal to sum of consecutive odd numbers, and how many odd numbers sum it is depends on whose cube that number is. For example, 125 is cube of the number 5, so that means it would be sum of 5 consecutive odd numbers. So this is the interesting pattern which is exhibited by the perfect cubes. Now comes our next challenge. Now, if we are given a number, any random number, so how do we decide whether that number is a perfect cube or not? Because not every number is a perfect cube. For example, we are given these two numbers, 15625 and 8000. If I ask you which is a perfect cube and which is not, how do you know whether this particular number can be written as product of one number multiplied to itself 3 times? How will you know that? So for that, we make use of the prime factorization method. So what is this method? You are all aware of the method, and the method still remains the same. While we were learning about perfect squares, you learned about this method. So in this method, what we do is, we first prime factorize the given number. So here the given number is 15625. So when you try to factorize it, you try to find out the smallest prime number which would completely divide this number. So the smallest prime number here is 5. So 5 into 3125 gives 15625. Again, it further gets divided by 5. 5 6 is 30, 5 2 is 10, 5 5 is 25. Again 5 1 is 5. 5 2 is 10, 5 5 is 25. Again 5 2 is 10, 5 5 is 25. Again 5 5 is 25. So we can write 15625 is equal to 5 into 5 into 5 into 5 into 5 into 5. So basically 1, 2, 3, 4, 5, 6. So 6 5s. So it is a product of 6 times 5. Now let's divide it into groups of 3 numbers. So 3 5s together will form one group. Again 3 5s together will form another group. So this can be written as 5 to the power 3. The first group can be written as 5 cube. Similarly, the second group can be written as 5 cube. So overall, we can say that 15625 is equal to 5 cube into 5 cube. So this can be written as 5 into 5 cube. So 5 into 5 is 25. So 15625 is equal to 25 cube. So that means this number can be written as cube of a particular number. So that means this is a perfect cube. Let's look at the next number, 8000. So let's prime factorize the number 8000. So the smallest prime number that divides it completely is 2. So let's take 2. 2 4s are 8. Again 2 2s are 4. Then 2 1s are 2. Now 2 5s are 10, 0 0. Then 2 2s are 4, 2 5s are 10, 0. Again 2 1s are 2, 2 2s are 4, 2 5s are 10. Now 5 2s are 10, 5 5s are 25. Again 5 5s are 25. So 8000 can be written as 1, 2, 3, 4, 5, 6. 6 times 2, that is 2 into 2 into 2 into 2 into 2 into 2 into 3 times 5. So 5 into 5 into 5. Again, let's divide it into groups of 3. So 3 2s together, again 3 2s together 3 5s together. So whenever we divide it into groups of 3, we need to make sure that each group contains the same number. Like 2 into 2 into 5 cannot be one group. So one group means the same number getting multiplied for 3 times. So this can be written as 2 cube into 2 cube into 5 cube. So this in turn can be written as 2 into 2 into 5 cube. So 2 2s are 4, 4 5s are 20. So this is 20 cube. So 8000 can be written as 20 cube, which proves that 8000 is also a perfect cube. Now, what do we mean when we say that 8000 is a perfect cube? That means you can actually make a cube if you are given 20 small cubes. So this shows that 8000 is a number which can actually form a perfect cube, and the length of each side of that cube is 20. For example, if this is your cube, where 8000 denotes the volume of the cube such that the length of each side would be equal to 20 centimeters. So each side would measure 20 centimeters such that the volume would be 8000. That means if you have 8000 small cubes, they can form a bigger cube. So let's try this number. We have to find out if this is a perfect cube or not. 243. So again the same technique. First we will do its prime factorization. So 243. So which is the smallest prime number that divides it completely? It's 3. So 3 8s are 24, 3 1s are 3, 3 2s are 6, 3 7s are 21, 3 9s are 27, 3 3s are 9. So how many 3s do you have? 5 3s. So 243 can be written as 3 into 3 into 3 into 3 into 3. So now let's divide it into groups of 3. So 3 3s together. Now we do not have 3 3s. We just have 2 3s. That means this can be written as 3 cube into just 3 into 3. So you do not have a 3 cube. You just have 3 into 3. So is it a perfect square? So now this number 243 cannot be written as cube of a single number. That means 243 is not a perfect cube. So maybe by mistake I told perfect square. So right now we are talking about perfect cube. So this 243 is not a perfect cube. Now can you think of any way by which you can convert, or you can convert this number to its nearest perfect cube? Now in order to make this number a perfect cube, you either need to multiply it by 3. So option 1 is you multiply the number by 3. So if you multiply by 3, what would happen? It will become 3 cube into 3 into 3 into 3. So that is into 3 cube. So this would be 3 into 3 cube, that is 9 cube. So if you multiply this number by 3, you would get 9 cube, which is 729. So 729 is definitely a perfect cube because it is cube of 9. So that is one option to reach out to the nearest perfect cube. There is another option that instead of multiplying this number by 3, you divide this number by 3 into 3. Because if you divide this by 3 into 3, then this extra part will vanish, because right now 243 is not a perfect cube because of the presence of this extra portion. So we just need to get rid of this extra portion. So to get rid of this, one option is multiply it by 3 so that this also becomes a cube. Second option is divide by 3 into 3. So when you divide by 3 into 3, then your product becomes 3 cube, because this 3 into 3 and the denominator 3 into 3 would get cancelled. So 3 cube would be 27. So when you divide it by 3 into 3, the 243 becomes 227. So that way, is by multiplying or dividing by a certain number, you can always reach out to the nearest perfect cube of a given non-perfect cube. So it's question time now. Let's try a few questions. Question number 1. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. Okay, so we are given two numbers, 72 and 675. So let's start with the first number. So what do? Our first step is to do prime factorization. So 72 is completely divisible by 2. So 2 into 36, again 2 into 18, 2 9s are 18, then 3 3s are 9. So 72 can be written as 2 into 2 into 2 into 3 into 3. So let's divide it into groups of 3. So 2 appears 3 times, but 3 appears only 2 times. So therefore this can be written as 2 cube into 3 into 3. So in order to obtain a perfect cube, what is that number by which this should be multiplied? So if we multiply it by another 3, then our job is done, because if there is one more 3, then it would become 3 cube. So therefore this number must be multiplied by 3. So we can say that it must be multiplied by 3. Now what will happen after it is multiplied by 3? Then it would become 2 cube into 3 cube. That is equal to 2 into 3 cube, which is equal to 6 cube. Right? So this would become a perfect cube. Similarly, let's look at the second one, which is 675. So here also first perform prime factorization. So it is completely divisible by 5. 5 ones are 5, 5 3s are 15, 5 5s are 25. Again 5 2s are 10, 5 7s are 35. Then 3 9s are 27, 3 3s are 9. So 675 can be written as 5 into 5 into 3 into 3 into 3. So when we divide it into groups of 3, so 3 occurs 3 times, but 5 occurs only 2 times. So that means we need to multiply it by 5. So if you multiply it by 5, then what will happen? So in that case, you will have 5 cube into 3 cube, which is equal to 15 cube. So this will again become a perfect cube. Question number 2. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So I think the approach would remain the same, just that instead of multiplying this time, what is that number by which we should divide? So the numbers are 135 and 192. So let us first do prime factorization of 135. So 5 into 27, 3 9s are 27, 3 3s are 9. Therefore 135 can be written as 5 into 3 into 3 into 3. Dividing into groups of 3, 3 occurs 3 times, but 5 occurs only once. So that means this number must be divided by 5, because if you divide it by 5, then 5 will cancel each other. So this 5 will be gone and we will be left with 3 cube, which is a perfect cube. So this number must be divided by 5. What about 192? Here also the same technique. 2 9s are 18, 2 6s are 12, 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 12s are 24, 2 6s are 12, 2 3s are 6. Therefore 192 can be written as 2 into 2 into 2 into 2 into 2 into 2 into 3. So groups of 3, 2 occurs 3 times, again 2 occurs 3 times, but 3 is left alone. So this number must be divided by 3 so that we can get rid of this extra 3. So the moment this extra 3 is gone, we will be left with 2 cube into 2 cube, which is equal to 4 cube, which is a perfect cube. Question number 3. Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. So this is how a cuboid looks like. So cuboid has sides 5 centimeters. Let's say this is 2 centimeters and this is 5 centimeter again. How many such cuboids will he need to form a cube? Now how can you make cube with a cuboid? By placing multiple cuboids like this, such that when you make that arrangement, all the 3 sides should be equal. So now let's think logically. How do you think we can place cuboids of this size so that we get a cube? So now when you look at this cuboid, 2 sides are equal, that is the length and the breadth are equal, both are 5 centimeter, but the height is 2 centimeter. So that means when we are trying to place more cuboids above, let's say if we place 5 cuboids above, so the height will become 5 into 2, that is 10 centimeter. So in that case, the width and the length should also be 10 centimeter. So we will have to place 2 cuboids side by side so that the length also becomes 10 centimeter. Right? Are you getting my point? Okay, let's look at another way of looking at it. So first of all, let us find out the volume of the cuboid, that is volume of this cuboid. So volume of the cuboid is given by length into breadth into height, which is equal to 5 into 2 into 5, that is equal to 50 centimeter cube. This is the volume of this cuboid, right? Now first let's check if this 50 is a perfect cube or not. So is 50 a perfect cube? No, 50 is not a perfect cube. In fact, 50 is not a perfect cube. That is why this is not a cube. That is why it is a cuboid, right? By now we understand any number which is a perfect cube, that number will be able to be the volume of a cube. So in this case, this is a cuboid. So 50 is not a perfect cube. Now let us do prime factorization of 50. Why am I doing this? I'll tell you. So we see when we look at its prime factorization, it is 2 into 5 into 5, which again proves that 50 is not a perfect cube, and that is why this is a cuboid and not a cube. Now, is there any number by which we can multiply this number such that it becomes a perfect cube? Because we want many more cuboids to be placed so that we get a cube. So any cube is formed by a number which is a perfect cube. So do you think that we can multiply this part with any number such that it becomes a perfect cube? Yes, of course, because here you see 5 occurs 2 times. To make it a perfect cube, we need one more 5, right? So one more 5 is needed. Similarly, 2 occurs 1 time. So to make it a cube, 2 more 2's are needed. So we need 2 2's and 1 5. So basically, this number must be multiplied by 2 2's, that is 2 into 2, and 1 5, that is 5. So 2 into 2 into 5. So if you multiply the given number with this number, then this becomes a perfect cube. How? So when you multiply this, it becomes 2 into 2 into 2 into 5 into 5 into 5, which is equal to 2 cube into 5 cube, that is equal to 2 into 5 cube, which is equal to 10 cube. So this 10 cube is a perfect cube. This basically means a cube with each side is equal to 10 centimeters. So 10 cube is 1000. So 1000 centimeter cube would be the volume of that cube such that each side is equal to 10 centimeters. So that means how many such cuboids do you need? To make this cube of 1000 centimeter volume, you would need these many cuboids. 2 into 2 into 5. What is 2 into 2 into 5? This is 20. So you actually need 20 cuboids to make a cube of volume 1000 centimeter square such that each side of the cube is 10 centimeters. So let us look at the arrangement. So now you see, if you have these cuboids, so if you place 20 cuboids like this, so first let's talk about the height. So we have to make the height as 10 because we saw that each side of the cube has to be 10 centimeter. So right now each side is 2. This is 2. Now when you place 5 such cuboids one above another, then your total height becomes how much? This total height becomes 10. Right? Now we also want the length to be 10. So right now this length is 5. So let us place another cuboid here. So then 5 plus 5 all together this becomes 10. So we place cuboids like this. So right now the height is 10, the length is 10. What about the width? So the width is right now 5. So what do? We place a cuboid in front of this. So this is also 5. So now the width has also become altogether 10. So therefore you place layer like this. So now overall this width is 10, length is 10, height is also 10. So this is actually a cuboid of volume 10 to the power 3, that is 1000 centimeter cube. And to make this cuboid, how many cuboids we needed? We needed 20 cuboids. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 here and 10 at the back layer. So 20 cuboids were needed. And by calculation also we could do it in this way. So 50 was not a perfect cube. That is why it was not a cube. It was not a cube but a cuboid. So we just, by prime factorization, we saw that what is that number which when multiplied with 50 will form a perfect cube, and we found that number as 20. So that means 20 cuboids will be needed to form a cube.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.